Alright, so today we are going to enter the new chapter for this semester. We have chapter 3, which is the periodic table. Okay, so 3.1, the classification of elements. Okay, as you can see here, this is an example of a modern periodic table. Okay, so we have a vertical column here. Okay, so it is labeled as 1, 2, 3, 4, 5, 6, 7 until 18. So the vertical column here represent the group. Okay, so we have the group here. Okay, and the horizontal row, okay, 1 2 3 4 5 6 7. Okay, the horizontal row here represent the period. Okay, so to classify the elements in the periodic table, is that we need to memorize all the elements in the periodic table? No, it is not like that. Okay, the easiest way to do so is by have a look at the electronic configuration of each element. So no need to memorize the periodic table actually. Okay, so for example, okay, so we start with block first. Okay, so how to identify the block? Okay, so block can be identified by have a look at the last electron field in the electronic configuration, which is we refer it to the highest energy electron. So the last electron field in the electronic configuration is the highest energy electron. For example, let's have a look at sodium. Okay, the proton number that for sodium is 11. So the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. So the last electron that is filled in this electronic configuration of sodium is in 3s subshell. Okay, this make the sodium is in block S. Okay, it's simple, just like that. Okay, so let's say if we have aluminium. Okay, aluminium, the proton number for aluminium is 13. So the electronic configuration for aluminium is 1s2, 2s2, 2p6, 3s2, and 3p1. So if you look at here, the last electron is filled in 3p subshell. So this make aluminium is in block P. Okay, and for the last example, so let's say if we have iron, which is the proton number of iron is 26. Okay, the electronic configuration for iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay, so we have 26 electron here. So since the last electron is filled in the 3d subshell, this makes the iron is in block D. Okay, so this is how we identify the block of each elements. Just have a look at the last electron that we put in the electronic configuration. So there are four main blocks in the periodic table. So we have block S, P, D, and F. Okay, so from this block, we can identify the valence shell of the elements. Okay, for S block, the valence shell of the elements are in N, S. So the N here indicates the outermost shell. Okay, means that the shell yang paling luar. So it is the outermost shell. Okay, for P block and S and P. So again, N here indicates the outermost shell. For D block and S N minus 1 D. So again, N here is represent the outermost shell. Okay, so for S block element, there are in two groups, which is group 1 and group 2. For P block, okay, they are in group 13 until 18. For D block, they are in group 3 until 12. For the F block is the inner transition elements. Okay, there are the lanthanides and actinide series. Now, let's have a look at the period. Okay, so period are numbered from 1 until 7. Okay, so we know that the position of period in the periodic tables are in horizontal row. Okay, so we have from period 1 until period 7. Okay, it is referred to the valence electron and its principal quantum number n, or the principal quantum number n is referred as the outermost shell. Okay, it is the outermost shell. Alright, so for example, if we have magnesium, okay, so magnesium, the proton number for magnesium is 12. Alright, so the electronic configuration for magnesium is 1s2, 2s2, 2p6, 3s2. So we have 12 electrons. Okay, so magnesium are in S block because the last electron are filled in the 3s subshell. So it is in block S. Okay, block S. Okay, so since the outermost shell, okay, the outermost shell of this magnesium is N is equals to 3, so it is in period 3. So the period for magnesium is 3. How about beryllium? Okay, the proton number of beryllium is 4. Alright, so the electronic configuration is 1s2, 2s2. This is for 4 electrons. Okay, so since the last electron is filled in the 2s subshell, so we know that beryllium is in block S, same with magnesium. Okay, but the outermost shell for the beryllium is N is equals to 2. Okay, so beryllium is in period 2. How about group? So we know that in the periodic tables, group are the vertical column. Okay, vertical columns in the periodic table. So the groups are numbered. So the groups are numbered from 1 until 18. So we have 18 groups in the periodic table. Okay, so to identify the group, we have to refer to the valence shell electrons. Okay, so just now we know that for S block, okay, so for S block, the valence shell for the S block is NS. So if the valence shell is NS1, so here indicates that the NS orbital got only one electron. It means that the valence electrons is 1. So that elements are in group 1. Okay, but if the valence shell is NS2, so we have 2 valence electron, the elements are in group 2. For P block, okay, the valence shell for P block, we are going to have a look at the NS and NP. Okay, so if the valence shell is NS2 and P1, so we have 2 plus 1, okay, equals to 3 valence electron. The group of the elements that have this valence shell are in group 13. Okay, so for the P block, okay, we have to add 10 from the valence electron. Okay, the valence electron add with 10 to get the groups. Okay, for valence electron plus 10, we have group 14. 5 valence electron plus 10, we have group 15, and until group 18. For D block element, okay, the valence shell is in NS and N minus 1 D. Okay, if the valence shell is NS2, okay, 2 electron, N minus 1 D, 1. Okay, so 2 plus 1 is equals to 3 valence electron. It means that the elements are in group 3. Okay, 4 valence electron, group 4, and until group 12. If you look at the group 6 and group 11, okay, we have the valence shell NS1 and -1d5. Okay, these two are for the anomalous case. Okay, the anomalous case in the electronic configuration. Okay, we have the anomalous for chromium, okay, for chromium and also copper. And last but not least, in classification of elements, okay, so we have metal, nonmetals, and metalloids. If you look at this periodic table, okay, so in the green color here represents the metals, okay, and then the blue color elements here represents the non-metals, and last but not least, the brown color here represents the metalloids.